what's the difference between ordinary and partial differential equations, or like what linear and nonlinear stuff like that? Going over what the definitions mean again.
Yeah, so for ordinary differential equations, you're just taking the derivative with respect to one variable. So notice that in these examples, it's always dx for each term and always dt. For partial differential equations, you can have partial derivatives, meaning you can take derivatives with respect to multiple variables. So notice that here we have dx and dy. Does that make sense?
Mhm. Okay.
So that's just the difference between ordinary and partial. Yeah, dependent variable is what you are taking the derivative of. So yeah, in this case, the top variable is the dependent, the bottom variable is the independent. If that makes sense. That's what they're referring to independent here in this case, yeah. Okay, linear and non-linear. Okay, a linear differential equations written in this form. Notice that each term consists of some ordered derivative. So this is the nth derivative of y, n minus 1 derivative of y, first derivative of y, and then and it's multiplied by some function a. And these functions can be different. They could be constants, they can be whatever. And the rule with linear differential equations is that each term can only have one derivative or like one, yeah, either one y or one derivative. You can't mix derivatives and dependent variables in the same term, if that makes sense. So that's what it's saying here. The dependent variable, which is y, is not multiplied with other dependent variables. So you can't have y's multiplied by y's in the same term. And dependent variables and its derivatives are raised to the first power. So that means you can't have like y squared in a term or like dy dx squared. If that makes sense. So if we compare these two, right? This one's okay. This is a linear differential equation because it's got dy dt by on its own, and then it just has some other function that goes along with it. Notice that this one is nonlinear because it's got dy dx, but it's multiplied by a y as well. So you can't have these two together. So in other words, you can't have y terms that are together in the same term.
You can only have one dependent variable, or you can only have the dependent variable by itself.
Yeah, per term, and then it's
Mm.
multiplied by some function in terms of t. So that's okay. But you can't have you want to look at these. So you can't have this because then you have the dependent variable and its derivative together. So that's why this is what makes it nonlinear. And the
Oh,
other thing is you can't have functions of your dependent variable either. So you can't be taking the sine of y, but we might as well look at these ones right now. Okay. So what do you think about these ones? You think that first one is that linear or nonlinear?
would the y squared be considered multiplying it by another, multiplying the dependent variable by itself?
Which one?
The or y cubed.
Yeah. So does that tell you is that linear or nonlinear?
Non-linear, right?
Yeah, nonlinear, right. The dependent variable has to be the first power. Or another way to think about it is that you can't apply a function to the y term. So you can't cube a y, you can't do anything else to the y term. Yeah, so that causes it to be nonlinear. All right, what about number two? Number two, you're going to
That's
have to
linear.
rewrite it. Yeah, why is that?
They're all separated, basically.
I think it's easier to see if you rewrite this. So if you subtract, I moved the 4x dy to the other side, and then I divide by dy dx. Notice I get y minus x is equal to 4x dy dx, right? So yeah, so in this case, right, notice that all the y terms, there's no functions that are being applied to them, and they're not multiplied by any other y terms, right? Y by itself is fine, and then we have dy dx multiplied by some x function, or an x term, not a y term, so that's okay. Okay, what about 3 then?
That would be nonlinear because it's the y prime times y.
Yeah, exactly.
And then it's we just shouldn't.
This part makes it nonlinear. Okay. Okay, yeah, order is just the highest derivative that's in the equation. Okay, so what do you think about these ones?
The order is based on the
The derivative.
highest.
Yeah, it's the highest derivative in the equation.
So this would be the
Fourth order and what you call linear or nonlinear.
I think it's linear.
Yeah, should be linear. All the derivatives are separated. There's no other dependent variables that go along. Linear. Is it ordinary or partial?
Partial, right? 'Cause you get the little funky symbol.
Yeah, that is how they denote it. So good. Okay, yeah, I guess we call it partial. Okay, and what about the other one?
It would be a second order.
And yeah, is it linear or nonlinear?
It's non-linear because it's near, right?
Yeah, nonlinear. Oh yeah, and
I
then
only got to say that are normal derivatives.
yeah, ordinary. Second order ordinary. No. Okay.